In Chicago, the John Hancock Center is the black, tapering tower that made the city's skyline famous. Yet 1,000 feet above Michigan Avenue, while it was still a skeleton of raw steel, an ironworker named John Rukavina walks a beam barely wider than his own boots. No harness, no net. Every man on the steel believes this tower is the strongest thing he has ever built. None of them knows that deep below the sidewalk, 26 of the John Hancock Center's concrete legs are hollow, filled with mud and water where solid concrete should be. This is the story of the machines that built Big John, and the flaw that almost killed it before it stood. By every rule of 1964, this tower should not exist. It was going to rise on the most elegant street in the city. North Michigan Avenue, the stretch Chicago called the Magnificent Mile, had been built to feel like a grand boulevard in Paris, a run of low, refined buildings and wide sidewalks where the wealthy came to shop. Into that graceful avenue, one man wanted to drive a black spike of steel 100 stories tall. The city argued about it in the newspapers. To some, a tower of this height on that avenue was an act of vandalism against everything the street was meant to be. To others, it was proof that Chicago could still build like no other city on Earth. Both sides agreed on one thing. If it went up, nothing about the skyline would ever look the same again. The man behind it was Jerry Wolman. He had grown up in the coal country of Shenandoah, Pennsylvania, the son of a grocer, a boy who left school early and built a fortune in construction and real estate before he turned 40. Wolman thought bigger than careful men liked. Only a year before, he had walked into a sealed auction and bought the Philadelphia Eagles for $5,505,000. Now he wanted the second tallest building on Earth, standing on the shore of Lake Michigan, beaten only by the Empire State Building in New York. Nothing about the plan sounded reasonable at the time. Only one building on Earth, the Empire State, stood taller than what Wolman was proposing, and it had worn that crown for more than 30 years. To match it on a shopping street in Chicago, on soft ground beside a great lake, seemed less like ambition than like a dare. And the man making the dare had never built anything close to it. To pay for it, Wolman went to the John Hancock Mutual Life Insurance Company. They agreed to finance the tower on a single condition: it would carry their name. To design it, he hired the most respected firm in Chicago, Skidmore, Owings, and Merrill. The lead architect was a fierce, brilliant man named Bruce Graham, and beside Graham stood a structural engineer whose ideas were about to change what a skyscraper could be. We will come back to him, because without him, this story ends in the mud. But first, the building ran into a wall that had nothing to do with engineering. Wolman did not want one tower. He wanted two, a tower of offices and a tower of homes, standing side by side. That is why it was called a center. To build the second tower, he needed one stubborn piece of land just east of the site. It belonged to a private club for the oldest money in Chicago, the Casino Club, whose members carried names like McCormick and Armour and Palmer, families who had shaped the city for generations. They had no interest in selling to anyone. As the story was later told in the Chicago Tribune, the developers wrote to the club president again and again, and she simply dropped the letters into a desk drawer and never replied. They were found only after her death. Whether every detail is exactly true, the outcome is not in question. The land never came. The two-tower plan died on the drawing board. There is a strange twist to the Casino Club story. Even after the club refused to sell, the tower still had to be built right beside it. To keep the old clubhouse from shifting while they dug the deep foundations next door, the builders would later pump roughly 44,000 gallons of grout into the ground beneath it. In the end, The men raising Big John had to hold up the very neighbor who had blocked their path. So Graham did something bolder. If he could not spread the building outward, he would fold it upward. He took the offices, the homes, the shops, the garage, all of it, and stacked them into one tower that grew narrower as it climbed, wide and heavy at the base, and tapering as it rose toward the sky. What Graham had drawn was not really a building at all. It was a vertical city. A person could live near the top, ride down to an office in the middle, buy groceries, and eat dinner without ever stepping outside, more than 1,000 feet in the air. Nothing quite like it had been attempted at this scale anywhere in the world. And it produced a tower so tall and so heavy that everything now hung on one question. What was holding it up? That question would nearly destroy them all, because a tower this size does not sit on the soil. It reaches down through the soft glacial clay of the lakefront to the solid rock far below, carried on enormous concrete columns called caissons. Everything now rested on those columns. If the concrete failed, 100 stories of steel would have nothing solid beneath them at all. If you want to see how a single hole in the ground can ruin a millionaire and nearly swallow a skyscraper, stay with us and consider subscribing, because the machines in this story do things you have never watched a crane do. We are going to climb this tower from the rock beneath it to the antenna at its peak, one machine at a time. The trouble began underground in the summer of 1966, long before most of Chicago knew the tower was coming. To reach bedrock, the crews drilled shafts 10 feet across, straight down through the clay, some of them nearly 200 feet deep, the deepest foundations ever sunk in the city. Into each shaft, they lowered a steel casing to hold back the soft, wet earth, then poured concrete to form a solid column. As the concrete filled the hole, the steel casing was pulled back out in sections to be used again in the next shaft. It was faster that way. It was also the mistake, because in some of those shafts, as the casing came up, it dragged the wet concrete up with it. Where the concrete pulled away, the surrounding earth and water rushed in to take its place. The columns looked finished from the surface. Under the ground, they were hollow, laced with pockets of mud where solid concrete was supposed to be. This was not a small operation gone slightly wrong. These caissons were the entire reason the tower could exist at all, the only thing standing between the finished tower and the soft clay that had frightened off builders for a century. Every one of them had to be perfect. And deep in the dark under Michigan Avenue, where no one could see them, some of them were quietly failing. For a while, no one knew. Then, on the 5th of August, 1966, one of the caissons moved. Under the weight of a single test column, it slipped about an inch in 24 hours. An inch does not sound like much, but a caisson is not supposed to move at all, not by a hair, and this one had shifted while carrying almost nothing. If it could sink an inch under one column, no one wanted to imagine what it would do under 100 stories of steel. The engineer beside Bruce Graham understood at once what that inch meant, and he made a decision that would cost a fortune and save the building. He stopped everything. On a project racing against its own budget, with a developer who had bet his fortune on speed, he halted the work and ordered every single caisson tested. The testing itself was a small feat of invention. Crews drilled narrow holes down through the suspect columns, then lowered instruments that sent sound pulses through the concrete and listened to what came back. Solid concrete answered one way, voids and mud answered another. One by one, the columns gave up their secrets. In a single caisson, the instruments found a pocket of loose earth 14 feet deep, with no concrete in it at all. When the count was finished, the result was staggering. Of 57 caissons, 26 were defective. Nearly half of the legs meant to carry the tallest building in Chicago were flawed. The tower everyone had feared would sink into the soft clay was in danger from something else entirely, the very concrete that was meant to hold it up. Fixing them meant drilling the bad columns out and pouring them again, deep under the streets of the magnificent mile. The numbers that survive tell the story in two scales. At the time, the Chicago Tribune reported that the corrective work added about $1 million to the budget and 6 months to the schedule. Later accounts of the full repair, supervised by the engineer himself, put the cost as high as $11 million. Either way, the delay was brutal, and it fell on one man. Jerry Wolman had guaranteed the project personally. Every idle day, every extra dollar poured into the ground came out of his own pocket. He had reached too far, and the hole under Michigan Avenue was pulling him down into it. By some accounts, the tower had pulled more than $20 million of Wolman's own money down into the ground before it was through, and a small army of creditors was closing in from every side. The dream that was supposed to make him one of the biggest names in the country was instead taking everything he had. On the 13th of December, 1967, Jerry Wolman filed for bankruptcy. To try to save himself, he was forced to give up the thing he loved most. He sold the Philadelphia Eagles, the football team he had bought only 4 years earlier, to a businessman named Leonard Tose. The sale closed on the 1st of May, 1969, for $16,155,000, a record price for a professional sports team at the time. The man who had dreamed the tower would never own it. The John Hancock Mutual Life Insurance Company, which had financed it from the start, stepped in and took control, and to their credit, they kept the same architect, the same engineer, and the same design. It is worth stopping to think about how close this came to catastrophe. Years later, an engineering journal looked back on those hollow caissons and wrote that the cost, in dollars or in lives, from the damage that might have struck a finished 100-story tower if those faulty columns had settled, was simply too horrible to dwell upon. A tower full of families, offices, and shops, standing on legs that could give way beneath them. That was the disaster that one shifting inch and one engineer willing to stop the world had quietly prevented. The foundation was saved. But saving it had only bought the right to face the next problem. Because a tower this tall, this slender, standing alone on an open lakefront, had an enemy that no amount of concrete in the ground could hold back: the wind. And to beat it, one man was about to throw out almost everything the world thought it knew about how a skyscraper stands. His name was Fazlur Rahman Khan, and he did not come from Chicago, or from money, or from any of the places that usually produced the men who shaped American skylines. He was born in 1929 in Dhaka, in what was then British India and is now Bangladesh, the son of a teacher. He was brilliant with numbers from the start. He won a Fulbright scholarship and crossed the world to the University of Illinois, and in only 3 years he earned 2 master's degrees and a doctorate in structural engineering. He joined Skidmore, Owings, and Merrill, and in time he became the only engineer among the firm's partners, a quiet man in a world of famous architects, holding a kind of power that came purely from the strength of his ideas. And his central idea would change the shape of cities. For decades, tall buildings had been raised like a rigid cage, a dense internal skeleton of columns and beams carrying the weight and fighting the wind. The taller you went, the more steel you had to cram inside, until the building was choking on its own structure. Khan looked at the problem and turned it inside out. What if the outside of the building did the work? What if the walls themselves became the structure? A hollow tube of steel standing against the wind like a giant hollow pipe, far stronger for its weight than any cage. Khan had already tried a first version of this idea on a smaller building not far away, an apartment tower of 43 stories. It worked, but the Hancock was where he would prove the tube at full, staggering scale on a tower more than twice that height. For the Hancock, he pushed the idea further than anyone had dared. He wrapped the entire tower in enormous diagonal braces, the giant crossing shapes that run up all four sides, and he tied them into the corner columns. Those diagonals are not decoration. They are the building. They carry the weight of the floors and the force of the wind together, gathering all of it and steering it down into the four corners of the tower and into the ground. Because the skin did the work, the inside could be opened up, free of the forest of columns that filled older towers, which was exactly what a building full of homes and offices needed. For the people who would one day live and work inside, this was not some hidden detail. It meant wide, open rooms and enormous windows where older towers would have stood dark behind their own columns. And here is the part that still astonishes engineers. By making the outside carry the load, Khan used far less steel than anyone expected. The Hancock needed only about 30 pounds of structural steel for every square foot of floor, no more than an ordinary building half its height. 100 stories, standing on the steel budget of a 50-story tower. In doing so, he had made the tower taller and lighter and cheaper and stronger, all at once. If you are enjoying this walk up the tower, take a moment to subscribe, because we are only halfway up, and the strangest machines in this story are still to come. But strength was not Khan's only worry. A tower this tall and this slim would sway in a strong wind, and if it swayed too much, the people living near the top would feel sick, far above the streets. Khan needed to know exactly how much movement a human body could feel before it became unbearable. And the way he found out is one of the strangest and most human moments in the whole story. He was walking through the Museum of Science and Industry in Chicago when he came upon a display with a washing machine, its platform slowly rotating. Khan stepped onto it, and standing there, feeling the gentle motion under his feet, he realized he could use a machine exactly like this one to test how much sway a person could take before they noticed it, before it turned their stomach. He used that idea to tune the tower, to make certain that even in a hard Chicago wind, the families in the upper floors would feel nothing wrong beneath them. The finished design allowed the tower to lean only about 5 to 8 inches in a 60-mile-per-hour wind, and it was built to stand up to winds far stronger, well past 100 miles per hour. This was one of the first towers in the world, shaped this carefully, against the wind, tested and proven before a single high beam was set. There is a temptation to say Khan invented all of this out of nothing, and that would not be fair to the truth. Chicago had always believed a building should show its bones honestly, a tradition running back generations. And the Hancock was not the first building in the city to stack homes and offices and parking together. The round corncob towers of Marina City had done that a few years earlier. What Khan and Graham did was take those ideas and drive them higher and harder than anyone had thought possible, into a single tapering tower, reaching 1/4 of a mile into the sky. Not everyone loved what they saw. When the design was revealed, some critics recoiled at the great black braces climbing the outside of the tower, calling it heavy, industrial, even ugly. A machine dropped onto an elegant avenue, but Graham and Khan had made their choice, and they held to it. A building, they believed, should be honest about how it stands. The Hancock would wear its strength on the outside for everyone to see. The design was finished. The foundation was fixed. Now they had to build the thing, and the shape of the tower, the very taper that made it beautiful, was about to create a problem that ordinary cranes could not solve. Here is the problem with building a tower that leans inward as it climbs. Every crane needs to reach out over the edge, drop a hook to the ground far below, and pluck a piece of steel up into the sky. On a normal building with straight walls, a crane can sit on top and reach straight out. But the Hancock did not have straight walls. Every side sloped inward as it rose. A crane sitting on top would have to reach out over open air, far beyond the base of the building, just to find the steel waiting on the street. No ordinary crane could do it, so the builders borrowed a machine from a completely different trade. They went to the world of bridge building and brought in something called a stiffleg-derrick creeper, a crane designed to climb the very structure it is building. Each of these machines was a giant in its own right, standing about 110 feet tall, with an arm reaching more than 100 feet out from its body. And it was strong. A single creeper could lift 38 tons of steel at a time, swinging it up from the street and setting it into the sky. Here is how it worked, and it is a genuinely strange thing to picture. Instead of sitting on top of the tower, each creeper clung to the outside of it. It was bolted to the steel columns by thick steel plates, hanging off the face of the rising building. From there, its long arms swung out, dropped its cable to the street, and lifted the next pieces of steel up the side of the tower. Once it had built the 3 floors above itself, the creeper hauled its own body upward, 3 floors at a time, dragged up guide rails by its own hoists, and locked itself onto the new steel to begin again. The machines climbed the tower they were creating, like something alive pulling itself hand over hand into the sky. At the base, where the tower is widest and the loads are heaviest, the 4 corner columns were monsters, each one about 39 feet long and weighing 100 tons, set in place by a crawler crane on the ground. Higher up, 4 creepers worked the 4 faces of the tower at once. The 2 on the long sides had to haul themselves up 31 times to reach the top. Above the 76th floor, as the tower narrowed, 2 of the creepers were taken down, and the 2 that remained were fitted with longer arms to reach across the tightening shape. Piece by piece, the steel went up. The connections that held it together are almost hard to believe in their sheer number. The workers drove more than 100,000 high-strength bolts and laid down over 165,000 top-pounds of weld to fuse the frame into one rigid body. In all, more than 42,000 tons of steel from United States Steel was into the Chicago sky, under a builder named Tishman, at a pace that reached 3 full floors every week. And now we have to talk honestly about the men who did this work, because their part of the story is usually told wrong. There is a legend, repeated on ghost tours and in comment sections, that workers died building the John Hancock Center, that the tower took its toll in bodies. We went looking for those men, in newspaper archives, in union records, in the histories of the building. And here is what we found. There is no record of a single worker killed during the construction of the Hancock. Not one name, not one date, not one report. For a tower of 100 stories, raised in the 1960s, before modern safety laws existed, that is close to a miracle. And it deserves to be said plainly rather than dressed up as a ghost story. That does not mean the work was safe. It was terrifying. These were the iron workers of Chicago's Local 1, many of them walking bare steel beams 1,000 feet in the air, with nothing beneath them, no nets, no harnesses, in a trade where a gust of wind or a patch of ice could end everything in a moment. The steel was engineered to stand for a century. The men who set it had nothing between themselves and the street but their boots and their nerve. They did it anyway, floor after floor, because that was the job. There is a reason the men who do this work have always been treated as a breed apart. To walk a beam a quarter of a mile above a city, in the wind, carrying tools, stepping over open gaps with the traffic crawling like insects far below, takes a kind of calm that most people will never understand. On the Hancock, they did it in the raw weather coming off the lake, month after month, climbing higher and higher above a city that shrank to toy streets far below. To feel how strong those nerves had to be, consider one of them by name. John Rukavina was an iron worker on that steel, and when the tower was nearing its full height and the whole country was celebrating the landing of men on the moon, Rukavina climbed to the very top of the antenna, 1,000 feet and more above Michigan Avenue, and hung a flag from it for the parade on the street below. Years later, he would go back up onto the roof of the building he helped raise, set up a grill, and cook steaks for his crew at $5 a plate. That was the kind of man it took to build Big John. If these are the kinds of stories you want more of, the machines, and the men that the history books leave out, the best thing you can do is subscribe and stay with us, because we are almost at the top now, and the tower is about to make history. It is worth pausing on how far ahead of its time the whole process really was. The steel climbed at a speed that ordinary buildings could not match, and the reason was the entire system that Khan and the builders had designed together, the tube that needed less steel, the creepers that could climb the taper, the enormous corner joints built ahead of time and snapped into place like pieces of a machine. Every part of the work had been thought through so the tower could rise fast and true. And rise it did, floor upon floor, narrowing as it went, until the Black Tower stood over Chicago like nothing the city or the world had ever seen. On the 6th of May, 1968, the last of the steel reached its place, and the John Hancock Center was topped out. When the final beam went up, the ironworkers signed their names across it and raised it into the sky, and the tower they had climbed for 2 long years was finally whole, from the street all the way to the sky. At that moment, it was the second tallest building in the entire world, taller than anything on Earth except the Empire State Building, and the tallest thing standing anywhere outside the city of New York. From the soft clay of the lakefront to the tip of its antennas, the tower reached about 1,500 feet into the air. The first residents moved in the following year. One of the very first was a man named Ray Hecla, the engineer who had helped design the building's own apartment floors. He carried his family up into the clouds above the magnificent mile before the tower was even finished, and made a home high above the streets of the city, inside the very machine he had helped create. And what a machine it was. A single tower that held offices, shops, restaurants, and hundreds of homes, stacked one above another, the vertical city that Bruce Graham had drawn when the second tower was taken from him. 23 floors of shops and parking sat at the base, 29 floors of offices climbed above them, and 48 floors of homes were stacked at the very top. Near the middle of the tower, where the offices gave way to the homes above, the builders placed something no other tower could claim, a swimming pool higher in the air than almost any other on Earth. Far above that, near the top, an observation floor would draw crowds from around the world, letting visitors stand 1,000 feet up and see for miles across 4 states on a clear day. Higher still, a restaurant near the very top let diners eat their dinner above the clouds, watching the sun go down over the lake. To carry people through all of it, the tower ran some of the fastest elevators in the country, racing them from the street toward the summit in well under a minute. People could live, work, and shop without ever touching the ground. It was an idea so bold that strangely few cities ever fully copied it, and the Hancock remained one of a kind. This channel exists to keep stories like this one alive, the machines and the men that the official histories leave in the dust. and it runs on nothing but the people who watch it. If Big John and the crew who raised it mean something to you, you can help keep these deep dives coming by buying us a coffee with the link waiting in the description below. Every single one of them keeps the next tower's story on its way. The tower's later life was not without its own hard lessons, and honesty demands we tell them straight, because they too are often stretched into something they were not. Decades after it was built, in 2002, a section of scaffolding hung for repairs tore loose in high wind and fell into the street below, killing several people in the cars beneath and shattering windows down the face of the tower. It was a real tragedy, and a reminder that even a finished building demands respect. Years later, in 2018, an elevator in the tower made headlines when a cable failed and the car dropped many floors before it stopped. The story spread that it had been a terrifying plunge to the bottom. In truth, the safety systems worked exactly as they were designed to, lowering the car in a slow, controlled slide until rescuers could reach the trapped passengers. Frightening, without question. But the machine held. The name on the tower changed in the end. In 2018, the insurance company that had rescued and financed it long ago finally had its name taken down, and the building became, officially, nothing more than its own street address on North Michigan Avenue. But no one in Chicago calls it that. To the city it was, and always will be, the Hancock. The men who built it just called it Big John, and Khan's great idea did not stay in Chicago. The hollow tube, the structure that carries its load on its skin, became the secret behind almost every super-tall tower that followed. The Sears Tower, rising only a few years later in the same city, used a whole bundle of these tubes to climb even higher. The tallest buildings in the world today, in New York, in Dubai, in Shanghai, all of them stand on the ideas that Fazlur Rahman Khan proved on the shore of Lake Michigan. The World Trade Center in New York rose as a pair of these tubes. The record breakers of the decades that followed reached higher and higher on the same simple truth Khan had uncovered, that a tall building is strongest when its outer walls carry the load. He died in 1982, only 52 years old. But the skyline of the modern world is, in a real sense, his signature across the horizon. So the next time you see that black tower against the Chicago sky, with its giant crossing braces climbing toward the clouds, remember what it truly is. It is a machine that had to be dragged out of a hole that nearly buried it, carried up on cranes borrowed from bridges, and walked into the sky by men with nothing at all beneath their boots. The John Hancock Center stands because a grocer's son bet everything and lost it, because an immigrant engineer stopped the world over a single inch, and because a crew of ironworkers treated 1,000 feet of open air like just another day at work. That is the true price of Big John, and it is written into every beam.